Hello students, in this lecture we are going to solve one more problem on block diagram reduction. So let's start. The question is to find the transfer function for given block diagram. So here for this block diagram we are having input as R of S and output is C of S. So we are going to follow the procedure that we have studied in previous lectures. What is that? First step will be to look for block in series, block in parallel or any minor feedback loop. So if we are having, we will be reducing it by using the corresponding rules. If not, we will be using other rule to create block in series, block in parallel or minor feedback loop. So for this problem, if we see, we can easily make out that this G2 and H2, they are forming a minor feedback loop. So we can reduce it by its closed loop transfer function. So now let's reduce this block diagram. So we are having R of S, and then after that we are having a summing point. Then we are having G1. Then after that we are having a summing point, and on this summing point we are having block G3 is ending here with positive signal. Then after that we are having G2 and H2 in minor feedback loop. So we can replace it by its closed loop transfer function. So it will be G2 upon 1, and now feedback signal is negative, so it will be positive here, G2 into H2, and after that we are having output signal as C of S. Now this output is sensed by feedback signal H1, and it will be ending on this summing point having negative signal value. So we have reduced this block diagram. Now we have to again see whether we are having block in series, block in parallel or block in minor feedback loop. So if you see here, we are not having. So what we need to do, we need to apply other rules to create block in series, block in parallel and block in minor feedback loop, so that we can reduce this block diagram further. So whatever we do, we should not create complexity here. Now one option can be is to shift the summing point after this takeoff point. Now what is going to happen? We are going to add complexity to this block diagram. So what else we can do? Better thing is to shift this summing point after this block here. So what we have to do? When we shift summing point after the block, that block we need to add in series with the feedback signal. So we will be adding G1 here with this feedback signal. So let's do that. So again we are having R of S as input, and now we are having block G1. Then after that we are having a summing point, that is this one, which we have shifted, and after that we are having one more summing point, that is this one. So now to this summing point we are having block G3, which is ending on this summing point here with positive signal, and after that we are having block, that is this one. So we'll repeat it as it is, 1 plus G2 into H2, and then we are having an output signal as C of S. Then after that this output is sensed, and now we will be having in this feedback signal this block G1, because we have shifted summing point over this block, and after that we will be having this H1 here, and then it will going to end to this summing point with negative signal value. So with this what we have did is we have created these two blocks in series, but still we are not able to reduce this block diagram further. So what we can do, we can again we have to see whether we can create block in series, block in parallel or minor feedback loop. So what we can do here, we are having two summing point next to each other. So what we can do, we can interchange them. Once you interchange them, then G3 and G1 will become blocks in parallel, and at the same time this block and these two blocks will going to form a minor feedback loop. So let's first shift these two summing point and reduce this H1 G1, which are in series, to one single block. So here we are having R of S, and then we are having block G1, Then after that we have summing point here. Now this summing point is this one, so it is interchanged. Because of that we can draw block G3 here, and it is ending on this summing point with positive signal. So now these two blocks are in parallel because both the signals are moving in forward direction. And after that we are having this summing point, the second summing point, and after that we are having block G2 by 1 plus G2 into H2, and then we are having output as C of S. Now it will be sensed, and this feedback signal will be having transfer function G1 into H1, and it is ending on this summing point with negative signal. So now we can see here we are having G3 G1 in parallel, and this block here and this block, they are forming a minor feedback loop. So we can apply corresponding rule to reduce it. So let's do that. So we are having R of S, and now we can replace G3 and G1 with a single block, and it will be having a transfer function as algebraic addition of these two blocks. So it will be G1 plus G3. Then after that we are having this minor feedback loop, so we can replace that minor feedback loop with its closed loop transfer function. So it will be G2 upon 1 plus G2 into H2 upon 1. Now this signal is minus, so it will be plus here G2 upon 1 plus G2 into H2 into this block. So it will be G1 into H1, and then we are having a output as C of S. Now we can see that these two blocks are in series, so we can apply corresponding rule to further simplify it. So we will be having R of S, and then we are having a single equivalent block here. So it will be again G2 upon 1 plus G2 into H2 upon 1 plus G2 into G1 into H1 upon 1 plus G2 into H2. And now since these two blocks are in series, so we have to multiply both the transfer functions. So once we multiply G1 plus G3 here, so it will be multiplied in the numerator. So it will be G1 plus G3 here. Then we will be having output as C of S. Now this transfer function we can further simplify, but since we have reduced it to simple form, we can write directly its transfer function, and in doing so we further simplify this one. So transfer function will be TF is equal to output, that is C of S upon R of S, and now transfer function will be G2 in bracket G1 plus G3 upon 1 plus G2 into H2 upon, now what we can do, we can cross multiply here so that we can have a common base here. So it will be 1 plus G2 into H2, that is multiplied with 1, and now we will be having this term here G2 into G1 into H1, and now we will be having a common base as 1 plus G2 into H2. So now what we can do, we can cancel this denominator and this denominator because they are same, and we will be having now simplified transfer function G2 G1 plus G3 upon 1 plus G2 H2 plus G2 into G1 into H1. So this is the transfer function of this block diagram here. So with this we'll end this lecture.